We present a tool that allows novices to create Infomages. The interface has 5 main areas. The resource input area where users can import their data, and select a background image retrieved from the web, or import their own image. The canvas area where users can preview the Infomage and manipulate the chart elements. The chart editing tools, which allow users to set various properties of the chart, such as the color, glow, size, axis, and various other properties. The distortion estimation indicators, that inform users about possible distortions in the various encodings. The post-processing tools, which allow users to format the text elements, and apply image filters to the background, giving the Infomage an artistic style. The tool allows users to import data from CSV files. Once a data file is selected, the data is loaded into a table, and a plot is generated in a preview pane. Our tool also retrieves images associated with the topic of data from the web. Users can either select one of these images, or import their own image. Let's move on to Infomage creation. We start with the fill style Infomages. To start off, we load the lipstick data set. The tool loads the data and retrieves a set of images related to lipstick. It would be nice to fill in an image of a woman's lips with the data. We do so by using the fill tools to embed the data. To fill the lips, we need to mark the lip area by creating a mask. This is done by using the masking tool. Here, draw a box around the object to be filled, in this case the lips. Then click on Generate Mask. This segments out the lips. We also provide tools to refine the selection if the object is not perfectly selected. Since the lips are perfectly cut out, let's move on to styling the Infomage. Users can select color schemes from a set of predefined color palettes. They can modify the colors if they prefer to do so. Users can also specify how the region should be divided. They can select from radial, horizontal, and vertical. In this case, radial seems to be the most suitable. Users can also specify the encoding upon which the chart will be radially divided. They can choose between angle, area, or arc length. The center of the pie chart can also be moved, and label distance from it can be changed. Once they are done, the Infomage can be saved as an image. We can also fill multiple objects in an image. Here, let's select the American troops in Afghanistan data set. For bar-like charts, images with multiple objects of similar size are preferred. As there are 3 data items, we will use an image with 3 soldiers. We have to create a mask for each of the 3 data items. This can become quite a tedious process as the number of data items increases. Once we have our masks created, we can edit the chart. We can change the color, offset the labels, as well as change the fill method. Now, let's move to overlay style Infomages. To start off, we load the traffic deaths data set. Again, the tool loads the data and retrieves related images. On selecting different images, the line chart is auto-aligned with certain objects in the image. While the placement of the chart is appropriate, it can be changed to a more refined or desirable position. Other properties of the chart such as its width and height, line color, thickness, and glow can be set as well. Additionally, the line can be changed from a sharp line to a smoother spline. Users can change the axis limits and the label spacing. Just like line charts, bar charts can be overlaid on an image. Here the trend formed with the bar peaks is aligned with certain objects in the image. After placing and coloring the chart, users can add finishing touches to edit the background. We can apply various filters to the background of the chart, thereby changing the possible interference it may have on the data. Text can be moved around, modified, and styled. In addition to embedding the data, we also estimate the amount of distortion in the chart. For example, in this case we tried to embed a pie chart into a pair of lips. Since the lips are not shaped like a perfect circle, some amount of distortion is caused to the data. At the bottom right, we report the distortion amount as a percentage error communicated through gauges. We report the error for all three encodings, in this case, area, angle, and arc length. We also report the average error across all three encodings. Users can also access a pop-up that shows the actual data values versus the erroneous encoding. In this case, since we used a pie chart, we show the comparison with a nested donut chart. The inner donut in green shows the true data values while the outer donut in blue shows the erroneous values. We also allow the user to optimize for all three encodings. Here, we use simulated annealing to minimize the error. For details, please refer to our paper.